Hello again. In this video I'm going to look a bit more at the properties of waves, as well as looking at frequency again. We're going to look at wavelength and amplitude. So whether we're talking about water waves, sound waves, light waves, any of the waves that we discussed in the last video, they tend to be presented in this way. We'll later come to call this a transverse wave, but for now all we need to do is pick out a few things from diagrams such as this. The first thing that you're going to need to know is what the top of a wave is called, so we call that a crest, and what the bottom of a wave is called, we call that a trough. When we're looking at wavelength, the easiest way to measure wavelength is from crest to crest or from trough to trough. So if we indicate that on this diagram, this would be one wavelength. That would be a wavelength there. We could also indicate it from trough to trough. So this would be another wavelength there. Later on we'll use wavelength in an equation, but for now I'm just going to call it lambda. That's the symbol that we use for wavelength. Looks a bit like an upside down Y, it's a Greek letter. So this would be a wavelength and this would be a wavelength. So both of these distances will be the same. It's also helpful to understand that one wave is equivalent to a crest and a trough. So that would be one wave. That can sometimes be useful when you've got diagrams that have a number of waves within them. The other thing that we need to be able to identify from a wave is something that we call the amplitude. Now the amplitude is half the vertical height of a wave, or as it says here, the distance from the axis to the top of the crest or the bottom of the trough. So it's half the vertical height basically. So this would be an amplitude, as would this be an amplitude. So it's half the height there. You'll see what I mean in a bit more detail in the next couple of examples that I do. So example 1 here, we've got a wave train there that looks similar to the one that I've just shown you. So you should be looking at this and thinking, right, how many waves have I got here? So you've got a crest and a trough, a crest and a trough. So this is 2 complete waves that we have within this distance. And what you'll usually have in examples like this is the full distance of this chain of waves. So in this case 22 meters. So if it's 22 meters for 2 waves, then we can be pretty sure that for one wave it's going to be 11 meters. So 11 meters for one wave, and that's how you find it from a diagram such as this. What you're usually given as well is the full vertical height of the wave, but of course we know now that the amplitude is half the vertical height. So instead of being 3 meters for the amplitude, it's going to be half of that. It's going to be 1.5 meters. Now frequency we can also calculate from the information that we're given, because as well as being given this information in the diagram, we're also told that those 2 waves are produced in a time of 5 seconds. So if you look back to the last video, our first equation that we introduced was F equals n over t, the number of waves divided by the time taken. So we've got 2 waves being produced in 5 seconds, which means that our frequency is going to be 0.4. And don't forget your units there, you'll always lose a mark if you don't put your units in. 0.4 Hertz. Example 2, it's a wee bit more complicated looking. We've got more waves within here, but the good thing about this is that we're not given the full distance of this chain of waves here. We're only given a portion of that, which does make it a little bit more manageable. So looking for the wavelength first of all, so it tells us we've got 0.4 meters here. Remember that as well as counting a crest and a trough as one wave, we can also count from crest to crest or from trough to trough. It's easiest to count from crest to crest here. So this is the crest here, that's one wave, and then that's 2 waves. So we've got 2 waves in a distance of 0.4 meters. So much like the previous example there, we can divide that by 2 to get what our wavelength is. so that's 0.2 meters for the wavelength. Amplitude, we get that from our vertical height here, but we know that the amplitude is not the full vertical height, it's only half of it, so we're looking at 0.25 meters. Again, for the final part, we've got a wee bit more information that will allow us to figure out what the frequency is. So we're given 125 waves in 20 seconds. So again, it's F equals N over T. 125 divided by 20 is going to give us 6.25 Hertz. Okay, go on and try the next quiz, which is on different properties of waves, including amplitude and wavelength.